Good afternoon, ladies and gentlemen. Welcome to this afternoon's webinar presentation with AIA Florida and JC Code and Construction Consultants. Today, we're going to talk about the 8th edition of the Florida Energy Code, Residential Provisions. And as indicated by the title, this is pretty much a basic course. We're not going to get into anything too technical or too mind-numbing. We're just going to look at basic provisions. We'll look at some changes that occurred in the 8th edition of the code. And if nothing else, everybody's going to get a really, really good refresher on what's going on with the residential provisions. So, as Wendy said, this is an HSW approved course for 2 hours. And my name is John Farinelli from JC Code and Construction. And I appreciate the privilege and the opportunity to be with you here today. So we will start with Chapter 1, Scope and Administration. And we're going to take a look right out of the gate at the scope. R101.2. This code applies to residential buildings and the building sites and associated systems and equipment. But that begs the question, what's a residential building under the provisions of the Energy Code Residential? Well, it is a defined term. For this code, includes detached one and two family dwellings and multiple single family dwellings, townhouses, as well as group R2, R3, and R4 buildings, 3 stories or less in height above the grade plane. Now, we need to talk about this for a little bit here, folks. Obviously, we're talking about structures built under the residential code, detached one and two family dwellings, multiple single family dwellings, townhouses. But R2s, R3s, and R4s, those are built under the building code volume. But that's neither here nor there because of the way the scope is written. As long as those R2s, R3s, and R4s are a maximum of 3 stories above the grade plane, they fall under the residential provisions of the Energy Code, even though they are built under the building code volume. Now, that begs the question, when you look at this definition, what's missing? What is missing? Anybody have a thought on that? Go take a look. R1s, transient lodging. They're missing. They're not there. The only thing you see here are R2s, R3s, and R4s. There's no R1s, which means when you go to design and construct an R1 transient lodging building, a hotel or motel, even if it's 1 story, it falls under the commercial provisions of the Energy Code. Interesting the way that shakes out with the R2s and the R3s and the R4s. All right. Intent 101.3. This code shall regulate the design and construction of buildings for the effective use and conservation of energy over the useful life of each building. This code is intended to provide flexibility to permit the use of innovative approaches and techniques to achieve this objective. This code is not intended to abridge safety, health, or environmental requirements contained in other applicable codes or ordinances. Now, this last bullet point here, ladies and gentlemen, clearly spells out that the Energy Code takes a back seat to life safety, as does the Accessibility Code and so on along those lines. Life safety is always of paramount importance. So the Energy Code, clear as a bell, takes a back seat to life safety. Now, next thing we should bring up and talk about is a mixed occupancy condition. 101.4.1. Where a building includes both residential and commercial occupancies, each occupancy shall be separately considered and meet the applicable provisions of the Florida Building Code Energy Conservation commercial provisions or Florida Building Code Energy Conservation residential provisions. Well, there's a little bit more involved than what you're actually seeing here. Let's go ahead and take that three-story building. It's mixed occupancy. On the first floor, grade level, you have Group B business, Group M mercantile, perhaps even an A3, a little restaurant. And on floors 2 and 3, you have apartments, R2s. Well, that's obviously a mixed occupancy condition. So you run both sets of calcs. On the first floor, you would run a commercial calculation. On floors 2 and 3, you would run residential calculations. But take that a step further now. It's now a 4-story building. First floor is still commercial with your group Bs, Ms, A3s, and so on. But floors 2, 3, and 4 are apartments, R2. Well, now you've exceeded the scope of the residential provisions. You're more than 3 stories above the grade plane. Therefore, the entire building must be run with a commercial calculation. Does that work? Does that make sense to everybody? Yes, no, maybe? Okay, very good. Not hearing anything to the contrary, so we will run with that. All right. Thank you, Nicole. Appreciate that. Got a response there. All right. Now, next up, exempt buildings, 101.4.2. Anything constructed under federal standards. And this next point here, under 4.2.2, hunting or recreational buildings less than 1,000 square feet, that comes out of state statute, Florida state statute. And as long as the hunting or recreational building doesn't have plumbing, electrical, or mechanical in it, it's exempt. And of course, historic buildings always get a break. But we have another section that deals with low energy buildings, and they are actually described in section R402.1. All right. Now, when we talk about the compliance methods that are available under the 8th edition of the Energy Code residential provisions, there are basically 3 methods. The prescriptive method, the performance-based method, and the ERI, the Energy Rating Index method. And the way the code is structured, if you look at R101.5.1 under compliance materials, states that the Florida Building Commission shall approve specific computer software, worksheet, compliance manuals, and other similar materials that meet the intent of this code. Commission-approved code compliance demonstration forms can be found in Table R101.5.1. All right, well, here is the Form R402, which is the prescriptive method. It's a hand calculation. All you do is fill out the form, and you're good to go. And then we have the Florida Res Check, which is software available from the United States Department of Energy. It is a prescriptive method, although it does use software. And you can run that Res Check calculation on your computer by downloading the software, or you can run the calc on the DOE software. And what that software does is it takes your R value input data and it converts it to a U value and compares that value to the values that are in the tables in the code. And as long as you are at or below the values in the table, you're deemed to be compliant. And then we have the 405, the performance-based method, which again is computer software. Now, what happened in the 8th edition of the code, because we do not update our codes anymore with the international codes as a base, we use the previous Florida code. the software from DOE was not updated for our 8th edition of the code, and therefore the Florida Res Check is no longer available for use under the 8th edition of the code. Now, you can still use ComCheck, which is the commercial version, and that is basically because that is included in the Energy Gauge software. So you can still do that. But for residential, it's gone. Now, when we talk about the residential provisions, who can run the calculations for energy software? Well, no license or registration is required to prepare the code compliance form for single-family residential dwellings, duplexes, and townhouses. And that's why you see a lot of contractors, mechanical contractors, HVAC contractors running the calcs. You also see private companies that have expertise in energy code. They can run the calcs. Don't need a license. Simple as that. All right, so far so good. Next up, we have another revision in the 8th edition of the code, and this is under R103.2, Information on Construction Documents. Construction documents shall be drawn to scale upon suitable material. Electronic media documents are permitted to be submitted where approved by the code official. Construction documents shall be of sufficient clarity to indicate the location, nature, and extent of the work proposed, and show in sufficient detail pertinent data and features of the building, systems, and equipment as herein governed. Details shall include, but are not limited to, the following as applicable. And then you get the laundry list. And there's where they added the 8th edition revision to number 1. The energy compliance path. That needs to be shown on the drawings now, and because it matters. You know, we mentioned that you have the prescriptive, performance, and ERI method. Well, depending on the method that you've selected is what drives the code sections that become applicable. So you need to show the path you have selected on the drawings. Nothing else changed. Installation materials and R values, fenestration U factors and solar heat gain coefficients, area weighted U factor and solar heat gain coefficient calculations, mechanical system design criteria. There's all about the service, hot water heating and such. Equipment and system controls, duct sealing, duct and pipe insulation, and air sealing details. So now we have 9 items that have to be shown on the drawings. All right. Next up, let's see. Question here from John. So we have the list that we are going to use R405. Yes, sir. A note on the drawing will suffice that you have selected the performance method under section R405. That will suffice, sir. But you have to be crystal clear. Which method have you selected? It needs to be shown on the drawings. All right. Here's 103.2.1, building thermal envelope depiction. The building's thermal envelopes shall be represented on the construction documents. Now, generally speaking, when we're looking at a set of residential plans, let's say it's for a 2-story house. And the first floor is masonry block, the second floor is wood frame construction. The designer of record, they're going to show you a section view from the foundation through the roof. And as long as they depict the insulation that's being installed, first floor, masonry block, 5-foil. Second floor, wood frame construction, fiberglass bat. Attic, ventilated attic, bat insulation at the ceiling line. Or spray foam if they're sealing the attic, whatever. And that's fine, as long as they show you where the insulation is located. Absolutely. Now, as far as inspections go, 104.2. The code official or his or her designated agent upon notification, shall make the inspection set forth in sections R 104.2.1 through 2.5. Well, because of our climate zone, ladies and gentlemen, you never see a footing or foundation inspection because we don't insulate those. We don't insulate those. Now, on the off chance that you have a basement and it's going to be conditioned space, yeah, you're going to insulate it more than likely, but the insulation will be on the inside of the basement walls. So pretty much, again, we don't generally see footing and foundation inspections. So we're left with the framing and rough, plumbing rough, mechanical rough, and then the building final. And then, of course, the code official can always request more inspections. All right, let's see what else we got here. Come on, computer. Well, that takes care of chapter 1. Let's jump now and we'll go to chapter 3 and start looking at some general requirements. First thing, climate zone. R301.1, general charging section. Table R301.1 shall be used in determining the applicable requirements from chapter 4. Locations are assigned a climate zone based on section R301.3. Now, here is a piece of the table I'm showing you here. Climate zones, moisture regimes, warm, humid climate designations by county. Well, you'll notice that the A indicating a moist climate, that's everywhere in the state of Florida. Didn't take a rocket scientist to figure that out. And the asterisk indicates a warm, humid climate. Well, again, every county in Florida. Every county. So we are moist and we are humid and we are warm. So when you look at the actual map, nothing's changed from the 7th edition. Here's your break point right about here above Palm Beach County, and then coming across below the line, climate zone 1, above climate zone 2. And as I said, all counties designated warm and humid, same as the 7th edition of the Energy Code. And every county up here, climate zone 2, with the exceptions of Broward, Collier, Hendry, Lee, Miami-Dade, Monroe, and Palm Beach, which are designated as climate zone 1. And it certainly makes a difference, certainly makes a difference. Just as a thought along those lines, above the line here, where you go into climate zone 2, heat pumps. Here below the line, if you wished, you could use a standard split air conditioning system. All right, so much for climate zones. Come on, computer. There we go. All right, moving forward now into section R303, and we're going to talk a little bit about materials, systems, and equipment. Here's 303.1.1.1.1, building thermal envelope insulation. R values referenced in Chapter 4 of this code refer to the R values of the added insulation only. The R values of structural building materials such as framing members, concrete blocks, or gypsum board shall not be included. But there is an exception under section R402.1.5 if you're using the total UA alternative, which is the U factor versus area. It's interesting when you think about the way the residential provisions are pretty much separate and distinct from the commercial. Because clearly here, when we talk about insulation, you can only use the actual R values. You don't get anything else for an R value. No framing members, concrete blocks, gyp board, air films, air spaces. You just don't get it. But under the commercial provisions of the code and under the total UA alternative, a design professional using the ASHRAE Handbook of Fundamentals can actually calculate an R value for an assembly, and you do get a value for things like the exterior siding, the framing members, gypsum board, air spaces, air films. You get a value for that. But that's commercial. You can't do that under the residential provisions. All right. Next section is 303.1.1.2, building thermal envelope insulation marks. An R value identification mark shall be applied by the manufacturer to each piece of building thermal envelope insulation 12 inches or greater in width. Alternately, the insulation installer shall provide a certification listing the type, manufacturer, and R value of insulation installed in each element of the building thermal envelope. For blown or sprayed insulation, fiberglass and cellulose, the initial installed thickness, settled thickness, settled R value, installed density, coverage area, and number of bags shall be installed or shall be listed on the certification. Section goes on. For sprayed polyurethane foam insulation, the installed thickness of the areas covered and the R value of the installed thickness shall be listed on the certification. For insulated siding, the R value shall be labeled on the product's package and shall be listed on the certification. The insulation installer shall sign, date, and post the certification in a conspicuous location on the job site. All right, question. It's rather obvious when we're talking about batt insulation, paperback batt insulation, let's get the R value printed on the paper. How do you know what the value is, the R value for spray foam? Where do you get that information? Any thoughts on that? I'm getting crickets here. Getting crickets. There we go. There's John. From the manufacturer of the insulation. Absolutely. Yep. From the manufacturer. It depends on the thickness of the insulation. That is correct. And it depends on whether or not it's closed cell or open cell. But that's where you get that information. Absolutely. Thank you for that, John. All right. Here is blown or sprayed roof ceiling insulation. The thickness of blown in or sprayed roof ceiling insulation, fiberglass or cellulose, shall be written in inches on markers that are installed at least one for every 300 square feet throughout the attic space. The markers shall be affixed to the trusses or joist and marked with the minimum initial installed thickness with numbers not less than 1 inch in height. Each marker shall face the attic access opening. Spray polyurethane foam thickness and installed R value shall be listed on a certification provided by the insulation installer. And an anonymous comment. I've seen those Icynene certificates posted in the attic. Not exactly conspicuous. Yeah, I got to agree with that. It really needs to be a little bit more obvious than that. The only thing that goes into the attic are the markers, the depth markers. And that's when you have fiberglass or blown in. But the spray foam doesn't do you a lot of good with the markers. Okay, that's kind of a no-brainer there. The certification needs to be posted generally in the garage by the electric panel or something like that. Yep, gotta love it. All right, we have a new section added to the 8th edition of the code. R303.1.1.3, air impermeable insulation. Insulation having an air permeability not greater than 0.004 cubic feet per minute per square foot under pressure differential of 0.3-inch water gauge, 75 pascals, when tested in accordance with ASTM E2178, shall be determined air impermeable insulation. All right, before we talk about this, I have a comment from Robert here. Is the requirement for posting insulation thickness, etc., apply only to new construction? Well, that depends. If you're doing an addition, that's new construction. But if you're working in an existing building, and let's say you're doing excuse me, some renovations or some remodeling, unless the work that you're doing meets the definition of a rehabilitated building, you're exempt from the energy code. So in essence, yes, yes, it's only for new construction. But if you are working again in an existing building and you're deemed to meet the definition of a rehabilitated building, then yeah, you'd have to post it also if you're doing work with the insulation. So, but for the most part, yeah, new construction. All right. Now, as far as this new definition goes here, folks, okay, the reason why it's in there is because there's some state statute that's getting ready to kick in here in July about air sealed attics and joist spaces. Okay. So we're going to talk about that here shortly. But at this point, I just need to talk a little bit about spray foam versus fiberglass bat and which is air permeable and which isn't. Well, most medium density spray foam insulation is air permeable, typically at a thickness of 1.5 inches or less. But closed cell spray foam is more or less vapor impermeable. But open cell, it can be vapor permeable. But on the other hand, most open cell foams are considered air impermeable at a minimum of 3.5 inches. So in other words, if you're using open cell foam, it's going to act like closed cell as far as the permeability goes once it reaches a certain thickness, usually about 3.5 inches. And another thing about closed cell, it's approved for use below the base flood elevation because it doesn't absorb water. So, what about fiberglass bats? Well, they are air permeable. The heat will move through them via the movement of air. The insulation will slow the movement down, but unfortunately, the heat transfer will occur. It will happen. So basically, we're talking about foam. Now, we'll take a little bit of a closer look at that new legislation that's kicking in here July 1st down the road a little bit. But before we do that, we need to move forward here and talk a little bit about fenestration product ratings under 303.1.3. U factors of fenestration products shall be determined as follows. 1. For windows, doors, and skylights, U factor ratings shall be determined in accordance with the NEFRC 100. 2. Where required, garage door U factors shall be determined in accordance with either NEFRC 100 or the ANSI DASMA 105. U factors shall be determined by an accredited independent laboratory and labeled and certified by the manufacturer. Now, this section goes on, but before we do, NEFRC, the National Fenestration Rating Council, they are the big dog when it comes to testing U factors, solar heat gain coefficients, condensation, air leakage. I mean, you name it when it comes to glazed products. All right. As I said, the section goes on. Products lacking such a labeled U factor shall be assigned a default U factor from table R303.1.3, paren 1 or paren 2. The solar heat gain coefficient and visible transmittance VT of glazed fenestration products, windows, glazed doors, and skylights shall be determined in accordance with the NEFRC 200 by an accredited independent laboratory and labeled and certified by the manufacturer. Products lacking such a labeled solar heat gain coefficient or visible transmittance shall be assigned a default solar heat gain coefficient or visible transmittance from table R303.1.3, paren 3. Now, all the big manufacturers out there, everybody, because this has been going on for years and years, they all get their products tested for these values. And the biggest reason why is if you don't, when you run your energy code calculations, you have to use the default values that are in these tables. And those values, folks, are pretty stiff. Pretty stiff. We'll take a look at the tables here in a little bit. But first, I want to review with you the actual NEFRC Energy Performance label. Let's take a look. Now, the first thing is the U factor. This measures heat loss. It tells you how much heat inside your home is escaping to the outside. The lower the number, the less heat escapes. If you're concerned about heating costs, you want a low U factor, and it runs from 0.10 to 2.0. We don't really worry about the U factor too much here in the state of Florida. And we're not really concerned about heating cost. But for us, it's the solar heat gain coefficient. This measures heat gain from the sun entering your home. The lower the number, the less heat enters. Lower heat gain coefficients can reduce cooling costs, while higher solar heat gain coefficients can reduce heating cost. It ranges from 0.0 to 1.0. Like if you take a look at this label here, it's 0.25. Now, the visible transmittance. This tells you how much natural light, without the heat, is entering your home. The higher the number, the more light enters. Higher VT may reduce your dependence on artificial lighting and help reduce utility bills. And it runs from 0.0 to 1.0. And this particular label, it's about halfway, 0.51. And then air leakage. This optional rating measures how much air will enter a room through a product. Products that measure less than or equal to 0.3, the fewer drafts you'll experience. Now, as far as NEFRC is concerned, this air leakage measurement, the testing is optional for them. But the code does set a maximum air leakage rate for windows and doors and such. And we'll look at that a little bit later down the road too. So as you can see, there is a lot of information in these NEFRC labels. So for us in Florida, solar heat gain coefficient, low numbers we're looking for. Low numbers. Absolutely. And of course, as you see here to the right, condensation resistance. That's also an optional test. Higher the number, the better a product resists condensation. And that becomes an issue when you have double pane glass with an inert gas in it, like argon or something like that. Sometimes if you get a little bit of leakage between the panes, it can start to condensate and such. All right. And from John, VT works backwards in Florida. The more light transmission, the greater the cooling load. Well, again, not necessarily, because again, if you go back here, John, and you look at the visible transmittance, that's how much natural light enters without the heat. Without the heat. So I'm not sure if that's a really, really big concern. But I'll tell you what is a concern when it comes to the VT is when you have condos on the beach, because now you have to worry about nesting sea turtles. And every jurisdiction out there running up and down the coast that has turtle concerns, they have it in a local ordinance what the maximum VT can be. Lights must shine directly down. They can't shine out onto the water and so on. But as far as the heat goes with the VT, not really a big concern in my mind. All right, now we mentioned earlier about products that weren't labeled having to use the values that are in the prescriptive tables. Well, take a look. Here's your default glazed fenestration U factors. Frame type, metal, metal with thermal break, non-metal or metal clad and glazed block. Single pane, double pane. Notice skylights are in a separate column altogether for either single or double glazing. And as I said, these values are pretty stiff. They're pretty stiff, even for double pane glass. I mean, you're looking at a 0.80. I mean, the lowest value in here is a 0.55, and that's still pretty stiff. Here's your default opaque door U factors. Same way. Uninsulated metal, wood. Insulated, non-metal edge, maximum 45% glazing. Any glazing double pane. And then the U factor values. And then the final table, default window, glass door, and skylight, solar heat gain coefficient, and VT. Single glaze, double glaze, and again, glass block separate because it's got that big old airspace between the panes. There's your solar heat gain and your visible transmittance. And again, these values, folks, are pretty stiff when it comes in comparison to a product that's been tested. All right. So far, so good. Let's move forward and talk about something that your average homeowner doesn't understand. People that are not in our business. Compressed insulation. You know, they think the more insulation you can stuff into a cavity, the better off you are. Well, we know better. Insulation that has been compressed to 85% or less of the manufacturer's rated thickness for the product shall use the R values given in table 303.2.1.1. These values are to be used except where data developed by an independent testing laboratory are provided. And the reason why we know these values are good is because they were provided by the insulation manufacturers. So just for giggles, take a look at R19 and you compress it down to 70% of its original thickness. Your R value drops to a 15. Yep, it makes a huge difference. Huge difference. All right, that takes care of chapter 3. Let's go to 4 now, and we'll talk about general provisions. Our first section is R401.2 compliance. Projects shall comply with one of the following. And this is what we had mentioned earlier about there being 3 methods available. Sections R401 through R404, which is your prescriptive method, the hand calculation. Section R405 and the provisions of section R401.4 through 404, labeled mandatory. That is your performance-based method. And as you can see, everybody complies with the mandatories. Or the Energy Rating Index, the ERI approach in section 406. The ERI is similar to the 405 performance-based method, but there are differences. Let's take a look. So, a prescriptive compliance method where you do everything on a list of prescribed requirements, the residential short form, or our performance compliance method by computer program, where the building complies as a whole by means of an energy simulation analysis tool, where the performance of the building as designed is compared to its performance when calculated with the standard reference design features. Effectively, the building must come in under an energy budget or an energy rating index. Again, computer software. Similar to the performance compliance method, but it includes all loads in the building with all calculations and inspection performed by an independent third party. All right, let's talk about this in depth a little bit here. When we talk about the prescriptive compliance method, it's a hand calculation. You fill out the form, okay? Well, that's all fine, well, and good. but it's limited. It doesn't have any trade-offs in it at all. It's like a cookbook. It tells you exactly what you can do and exactly what you can't do. There is no flexibility in it. It works fine for renovations, small additions, but if you're trying to do a prescriptive method when you're building a new home, you're shooting yourself in the foot. You really, really are. Now, the performance-based method under 405, on the other hand, it's got a lot of flexibility in it. You input your data and it is compared against the SRD, the standard reference design. And it's got trade-offs in it. Let's say the standard reference design is R38 for attic insulation. And for whatever reason, you want to put R30 in there. Okay, that's fine. You're not as energy efficient as the standard reference design in that category, but you can make it up someplace else. More efficient water heating, more efficient mechanical systems. Trade-offs. It's an energy budget. It's not a set of energy code minimums. As long as your design comes in as 95% or less of the budget, the energy budget of the standard reference design, you're golden. You're good to go. Now, the ERI, similar to the 405 in that it is a computer software driven program. However, it is different. It looks at all loads. It looks at appliance loads. It looks at plug loads. The only energy load that it does not look at is the energy used to recharge an electric vehicle. It also takes it out of the hands of the building department. When somebody chooses an ERI method, they need a third-party independent energy professional, such as a ResNet rater. They do it all. They review the plans, they do the calculations, they do the inspections. Takes it right out of the hands of the building department. So those are your methods. So go ahead, take a look at the 402 form. Notice it's 2023 code. The form is 4 pages long. And just as a point of interest, take a look at climate zone 1, okay? Your ceiling R values are 38. In climate zone 2, or excuse me, in climate zone 1 it's a 30. In climate zone 2 it's a 38. Okay. And that's it. There's no trade-offs. That's what you're going to do. End of story. Now, looking at the 405. Again, notice 2023 code gives you everything listed. There's your windows. There's all the labeling with the U factors and such. Wall types, ceiling type, ducts, cooling systems, heating, service water heating, credits. But this is what's really the most important thing to talk about right now. Total proposed modified loads 31.24. Total baseline loads 34.38. All right. The difference between these two numbers is the spread, because this is what's going on here. Proposed is your design. Baseline is the standard reference design, the SRD. As long as your proposed modified loads are lower than the baseline, you pass. Well, think about this for a second. When you have a spread that's very, very tight, all you need to do is change something up here in the input data, and it can blow you out of the water. It can blow you out of the water. Just for argument's sake, let's just say, oh, R30 in the attic. Change that to a 19, R19. and it's going to change this spread down here, it could cause you to fail. Absolutely. Same thing with water heating or the efficiencies of your mechanical systems. So always keep an eye on the spread. How tight is it? How much flexibility do you have left? Absolutely. And John is saying you can have a less than 10% higher value and still pass. Well, again, it's 95%. You have to come in at 95% or less. All right. Let's take a look here at the ERI. Notice, again, 406 ERI report, getting that pass. The ERI for this house is 50. Maximum allowed ERI, which is set by the code in section 406, is 58. ERI, if the house is built to the 2006 code, is 100. Because this is actually how this method works, okay? You're being compared to the energy efficiency of a home built under the 2006 International Energy Conservation Code residential provisions. At that time, the value was 100. And that's what you're being compared to. I can't stress that enough. So, with having an ERI of 50 for this house, you are 50% more energy efficient than a home that was built under the 2006 edition of the International Energy Conservation Code. All right. And John is putting in another comment here about sometimes you can do so much trade-off, for instance, that you could double up, triple up the insulation in the ceiling and have nothing in the walls, and it still might pass. Well, to a degree, I think that's true, John. But still, you're going to end up getting hammered there, because you can't just keep dumping insulation in. The software itself's not really going to allow you to do that. So you can do it to a degree. All right. So that takes care of the ERI. I think we beat that up pretty good. Oh, and one other thing while we're on the ERI here. In future code cycles, if they wish to make this more efficiency, all they have to do is adjust this number. Take the 58 and drop it. That's all they have to do. Nothing else. All right. Let's talk now about the EPL card under 401.3. The building official shall require that an energy performance level display card be completed and certified by the builder to be accurate and correct before final approval of the building for occupancy. Florida law, section 553.9085, Florida statutes, requires the EPL display card to be included as an addendum to each sales contract for both pre-sold and non-pre-sold residential buildings. The EPL display card contains information indicating the energy performance level and efficiencies of components installed in a dwelling unit. The building official shall verify that the EPL display card completed and signed by the builder accurately reflects the plans and specifications submitted to demonstrate code compliance for the building. A copy of the EPL display card can be found in Appendix RD. Now, before we look at that EPL card, there's something I think is important to talk about. And this applies not only in the energy code, but all codes in Florida. We all know that appendices are not considered to be part and parcel of the code unless they are specifically adopted on a local level by the authority having jurisdiction. Yes, that is absolutely true. However, there's one little caveat to that. When the appendix is referenced within the body of the code, then it becomes part and parcel of the code automatically. And just like you're seeing here with Appendix RD, that's where they get the standard reference design goodies. It's part and parcel of the code. It does not need to be adopted on a local level because it's referenced within the body of the code. All right, let's go ahead now and let's bring up that EPL card. You can take a look here. Again, 8th edition of the code comes out of the 405. And just as a point of interest, the big dog, so to speak, when it comes to the software for the 405 and the 406 for that matter, is Energy Gauge software. The EPL card is produced by that software. In addition, with that Energy Gauge software, it'll take all your input data when you run your energy code calculations and take all that data and drag it over into your heating and cooling load calculations. Jackpot. And that's another thing to mention. When you run your energy code calculations, you can run them in all 4 cardinal directions, north, south, east, and west. And if you can get it to pass in all 4 cardinal directions, you're done. Because you know it'll pass no matter how the house is sited. But you can't do that with heating and cooling load calculations. They have to be done site specific for the specific orientation of the home on the lot. It makes that big a difference. If you try to run worst case, you're going to be right 1 out of 4 times, and that's it. Now, I do have a comment here. Is there a good alternative to Energy Gauge that you know of? I don't have any personal experience with any of the other softwares, but there are softwares out there that the commission has approved, and you can get a list of those by going to the Florida Building Commission website. All right, let's go ahead and bump it up a notch, so to speak, and let's go to the building thermal envelope. And this is section R402. 402.1, general prescriptive provisions. This is what we had mentioned earlier about specific low energy buildings being exempt. Well, take a look. The building thermal envelope shall meet the requirements of section R402.1.1 through 1.5. Exception. The following low energy buildings or portion thereof, separated from the remainder of the building by building thermal envelope assemblies complying with this section, shall be exempt from the building thermal envelope provisions of section R402. 1.1. Those with a peak design rate of usage less than 3.4 BTU an hour times a square foot of floor area, or 1 watt per square foot for space conditioning purposes. 1.2. Those that do not contain conditioned space. Now let's stop right there for a second. Keep in mind that if you are deemed to be a low energy usage building, or if you do not have conditioned space, yes, you're exempt from the thermal envelope provisions, but that's it. If you've got electric lighting in there or service water heating, you still have to comply with that. You're only exempt from the building thermal envelope provisions. Now, item number 2, log homes designed in accordance with the ICC 400. That was added to the 7th edition of the code, and there was a specific reason for it. When you design a log home under the ICC 400, it has in the standard provisions for energy efficiency. So it takes care of it all on its own. All right. Subsection under 404.1 or excuse me, 402.1.1 vapor retarder. Wall assemblies in the building thermal envelope shall comply with the vapor retarder requirements of Section R 702.7 of the Florida Building Code Residential or Section 1405.3 of the Florida Building Code Building as applicable. Let's take a look at the residential code. Here is Section R 702.7, vapor retarders. Vapor retardant material shall be classified, and it goes on ad nauseum. But what's important for us at this point is the exceptions. Look at number 4. A vapor retarder shall not be required in climate zones 1, 2, and 3. Simple as that. You don't have to do it. You don't have to do it. We do not need a vapor retarder in our climate zones in the entire state of Florida. And when you look at section 1405.3 in the building code volume, it's got similar language in there. There's just no need for us to use vapor retarders in the state of Florida. All right. Let's move forward now and look at 402.1.2 insulation and fenestration criteria. This is a prescriptive table. The building thermal envelope shall meet the requirements of table R 402.1.2 based on the climate zone specified in chapter 3. Well, when you look at the table, and as you can see here, climate zones 1 and 2, climate zones 1, the fenestration U factor, because it's really not that important to us, it's not required. You look at climate zone 2, South Florida, or excuse me, northern part of Florida, above Palm Beach County. It's a 0.40, because yeah, it can get a little cold up there in Tallahassee and such. Skylight U factor's got a little bit of a difference in it. Notice how it's in a separate column from your glazed fenestration solar heat gain coefficients. Those values remain the same, 0.25 all zones. Ceiling R value, 30 and 38. The wood frame wall value, same. Mass wall R value, 3 and 4, 4 and 6. Floor's the same, 13. But look at your basement wall, your slab insulation and crawl space. All the values are 0 across the board. We just don't need to do it in our climate zones. Now, there are a ton of footnotes to this table. A ton. So, briefly, R values are minimums, U factors and solar heat gains are maximums, and so on. Talks about the fenestration U column and so on. But really, what I really want to show you here is this, and because it's a Florida specific, this is footnote J. For impact rated fenestration complying with section R 301.2.1.2 of the Florida Building Code Residential, or section 1609.1.2 of the Florida Building Code Building, the maximum U factor shall be 0.65 in climate zone 2. And that is a Florida specific amendment. Okay, now going back and looking at the table, climate zone 2, U factor. By the table, it's 0.40. But by the footnote, you can bump it to 0.65. And again, that is a Florida specific amendment. The International Energy Conservation Code does not address impact rated fenestration at all. Not at all. All right. Now, other footnotes of interest, they're there. Take a look at them when you get a shot. And John Ahern, R38 required in the attic. All right, let's go back and look at the table. Remember, this is a prescriptive table. If you are doing a prescriptive method, yes. In climate zone 2, it would have to be a 38. In climate zone 1, it'd have to be a 30. But remember, if you're doing a 405 performance-based calc, you can trade that off. In other words, let's say you're in climate zone 2 and you don't want to put 38 in the attic. You could put 30 as long as you make up that lack of insulation efficiency in other areas. And anonymous thought here. Why does Florida not need vapor retardants when we have high humidity that our AC system soaks through the walls? If you were to put a vapor barrier in walls in Florida, you'd end up getting moisture and condensation in there, which would lead to mold, mildew, and rot. You want the walls to breathe. We're going to talk about ventilation here in a little bit. And Leah, does the table change if insulation is continuous? For example, cavity wall insulation will have many thermal breaks, reducing overall efficiency of the assembly. Okay, let's talk about that for a second. Okay, here's 3 and 4 for your mass wall R value. Okay, and that is footnote I. Take a look. I. The second R value applies when more than half the insulation is on the interior of the mass wall. So really what you're looking at here, okay, and going back to the table, you don't see it done too often to have cavity insulation and then exterior insulation with mass walls. It's more common when you have a wood framed wall, like take a look here. And again, we really don't even do that in our climate zone. There's no need to. But when you start getting into colder areas in other parts of the country, take a look at what 13 plus 5 means under footnote H. The first value is cavity insulation. The second value is continuous insulation on the outside, like insulated siding. So 13 plus 5 means R13 cavity insulation plus R5 continuous insulation. So again, it may sound like a good idea, and you could certainly do it if you wanted to, but code doesn't require it. In our climate zones of 1 and 2, when you're doing wood framed walls, you can get away with just cavity insulation. That's it. That is it. But Leah, you do make a good point about thermal breaks, okay? Because when you look at the prescriptive tables, it's talking about wood frame walls, okay? But when you start talking about using metal studs and such, the thermal breaks go through the roof, and that's a different animal altogether. So good question, Leah. Thank you. And another one from Mr. Anonymous, is the ceiling R value the same as the roof R value? Yes. That's when you have a ventilated attic with the bad insulation at the ceiling line. Absolutely. All right. Good stuff. Good conversation. Thank you, folks. Appreciate it. Let's move past the footnotes, and this is what I had mentioned earlier. R value computation, 402.1.3. Insulation material used in layers such as framing cavity insulation or continuous insulation shall be summed to compute the corresponding component R value. The manufacturer's settled R value shall be used for blown insulation. Computed R value shall not include an R value for other building materials or air films. Where insulated siding is used for the purpose of complying with the continuous insulation requirements of Table R 402.1.2, the manufacturer's labeled R value for insulated siding shall be reduced by R.6. The reason why they require you to drop the R value by 0.06 if you're using insulated siding is because of the air film between the siding and the subsheathing. You don't get a value for that. All right. Now, we mentioned a little bit ago, I guess, about the U factor alternative under 402.1.4. They have a table, 402.1.4. And remember how we said that if you were to run, when you could, a res check where it took the R values of your input data and converted them to the U factor and compared it to the table? Well, this is the table. So, and let me go ahead and finish with this, and I'll get to a couple of questions here. An assembly with a U factor equal to or less than that specified in table R402.1.4 shall be permitted as an alternative to the R value in table R402.1.2. Now, what exactly is the U factor? How's it calculated? Well, it is basically the inverse of the R value. U value equals 1 over the sum of all R values. And the R value, you can also call that thermal transmittance, which translates into lower U values, better insulation. Okay, Leah's asking, will you touch on the use of closed cell versus open cell in Florida? Well, I mentioned earlier that closed cell foam is allowed for use below the base flood elevation because it doesn't absorb water. So I'm not exactly sure if you were looking for something more on that, Leah. And let's see, David is asking, where were the exceptions found for the requirement for the vapor retarder? That's in Chapter 7 of the Residential Code volume, David. Chapter 7. All right. Now, sometimes, folks, when we're looking at some of these code sections, it's a lot easier to show you what was in the code that got struck out and what you ended up with. And that is the case here. What you're looking at under 402.2.4 was access hatches and doors in the 7th edition of the code. Well, it got rewritten in the 8th edition, the whole thing. Here's what you got now. Access hatch doors and insulation retention. Vertical or horizontal access doors from conditioned spaces to unconditioned spaces, such as attics and crawl spaces, shall be weather stripped and insulated to a level equivalent to the insulation on the surrounding surface. Access that prevents damaging or compressing the insulation shall be provided to all equipment. Where loose fill insulation is installed, a wood-framed or equivalent baffle, retainer, or dam shall be installed to prevent loose fill insulation from spilling into the living space, from higher to lower sections of the attic, and from attics covering conditioned spaces to unconditioned spaces. The baffle or retainer shall provide a permanent means of maintaining the installed R value of the loose fill insulation. All right, let's talk about this for a minute here, and then I'll get to a couple of questions here. I think every one of us probably has opened up an attic scuttle and got snowed on by blown-in insulation. So these changes are just an expansion of the requirements to try and keep that blown insulation in place. And the exception, there's no change to that, and that was addressing and does address vertical doors that provide access from conditioned to unconditioned spaces. All you need to do is look at the fenestration requirements in table 402.1.2. And again, let me just show you this little graphic here, and then Willie will answer a couple of questions here. So notice that the weather stripping installed on the pull down face of the panel, gaps have to be sealed, weather stripped, and there's your insulation dam right on both sides for that blown in insulation. But the hardest thing for people to understand is this access opening itself has to be insulated. Well, how are you going to do that with a set of pull-down stairs? Well, they have products out there now. It almost looks like one of those silver emergency space blankets. It's designed to go over the access opening and get secured. Pull down the ladder. It's got a zipper. Unzip it, flop it open, you're in. And it has the same R value as the surrounding areas. You can get them at different values. So it's nothing that can't be accomplished. But that's always been a challenge is how do you insulate the pull down stair? You can do it now. All right. And Chris is saying he's heard roofers prefer open cell and attic spaces that are part of the thermal envelope simply because if there is a leak, open cell makes it a little easy to detect. And that is true. That is true because closed cell doesn't absorb water, it'll block it. And Leah is saying, is there any reason to use closed cell in conditioned attic, or if that just causes and risks humidity moisture to be trapped? Well, again, you see, most cases we're using open cell when we seal an attic. And remember too, that there's requirements in the code to have a vapor port in the attic when you seal it with spray foam insulation. So there are provisions in the code to try and deal with that issue. Absolutely. All right, next item. Mentioned this earlier when we looked at the prescriptive table. 402.2.10 slab on grade floors. Slab on grade floors with a floor surface less than 12 inches below grade shall be insulated in accordance with table R 402.1.2. Well, as you saw in the table, the required R value in climate zones 1 and 2, the entire state of Florida, is 0. But there's another reason, exception. Slab edge insulation is not required in jurisdictions designated by the code official as having a very heavy termite infestation. You think that's Florida? Well, the residential code has a figure in it, R301.2 paren 6, termite infestation probability map. Well, very heavy, the dark shaded areas, the whole southeastern part of the United States. So, yeah, we got critter issues. Now, one thing that I find interesting, and I've never been able to get a straight answer as to why, that exception about heavy termite area, that's not in the commercial provisions of the Energy Code. In fact, when you look in the tables in the commercial provisions, it tells you that if you have a heated slab, you have to insulate it. And again, the exception's not in there. And I've never been able to get a straight answer for that. It would just seem to me that it should be applicable for both the residential and commercial provisions, but that it's just not the case. All right. Next, we need to talk about sunrooms. Here's 402.2.13. Sunrooms enclosing conditioned space shall meet the insulation requirements of this code. Exception. For sunrooms with thermal isolation and enclosing conditioned space, the following exceptions to the insulation requirements of this code shall apply. 1. The minimum ceiling insulation R value shall be R19 in climate zones 1 through 4 and R24 in climate zones 5 through 8. 2. The minimum wall R value shall be R13 in all climate zones. Walls separating a sunroom with thermal isolation from conditioned space shall meet the building thermal envelope requirements of this code. You know, sunrooms can be a real challenge from an energy code standpoint because of all the glass that's in them. And in fact, I'm sure some of you remember years ago when some of the fast food restaurants like Wendy's, maybe even Burger King, they used to have that one section of their dining room that was almost under a solarium. It had that arched glass that used to cover a good side of the building. Well, they pretty much got rid of that pretty quick because it was so hard to heat and cool. And that's just a perfect example of sunrooms with all that glass in them. Now, for our purposes here, thermal isolation. All right, well, what do we mean by thermal isolation? Well, again, it is a defined term in the code. Physical and space conditioning separation from conditioned spaces. The conditioned spaces shall be controlled as separate zones for heating and cooling or conditioned by separate equipment. So, bottom line, if you want to invoke those provisions, you need separate heating and cooling equipment for the sunroom or separate zones. Separate zones. Excuse me. All right. Now, other provisions, of course, the wall dividing the sunroom from the dwelling, that has to be treated like it's an exterior wall. In other words, it has to be fully insulated. All right, John, if all of Florida is zone 1 or 2, why mention all the other climate zones in the Florida Building Code? Oh, when we develop our codes, John, there's a lot going on there. And the problem you have to be consistently aware of is when you start deleting things out of the code, you're gonna miss things because one section of the code points you to another section, and you end up with dead ends in the code. And the rule of thumb for the longest time was mess with the code, the base code, as little as possible. If something is not applicable, ignore it. Just like if you're designing a business occupancy, you're not going to take all the stuff out of the code applicable to assembly and apply it to that building. It doesn't apply, you ignore it. So that has always been the thought. Don't mess with the code unless you absolutely have to. If it's not applicable, just ignore it. I mean, it wasn't until the 8th edition where they decided to delete all references to snow loads and seismic loads. Takes time. All right, Anonymous. So sunrooms do not have to meet the energy code, only the wall and ceiling R value? No, 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 no. No, 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 no. Go back and take a look. Okay. R values for the ceiling, R values for the walls. But remember, when you run your energy code calculations, because it's got thermal isolation, which means it is conditioned space, that means you're going to have to include all this glass in your energy code calculations. You're going to have to meet the solar heat gain values, the U values, the visible transmittance. Absolutely. All this section is telling you is what the wall and ceiling insulation has to be. You do not get off the hook from the glass. You do not. All right. Now, next thing we need to talk about are common walls, ceilings, and floors under section 402.2.14. You run into this issue with townhouses, especially, or apartments, condos, things of that nature. Walls, ceilings, or floors separate or common to separate conditioned tenancies shall be insulated to a minimum R11 space permitting. Exception. Mass common walls shall be insulated to a minimum of R6. All right, well, the first thing is why do we have to insulate walls, floors, or ceilings common to a separate tenancy? Well, the simple answer for that is because you have no control over what your neighbor does. It could be 110 degrees outside and you've got your air conditioning running full blast, and your neighbor says, well, it's really nice outside. I think I'll open all the windows. and shut off the air. That's the reason. You have no control over what your neighbor does. Now, as far as mass common walls, why do they get a break from R11 down to R6? Well, you got to consider the fact that mass walls are built of dense materials such as concrete block, poured reinforced concrete, brick, ICF, and traditional building materials and methods like adobe, solid logs, rammed earth. They're also considered mass wall materials, and in fact, take a look at the definition. Mass wall, a wall with a heat capacity exceeding 1, 7 BTU an hour square foot, or 5 BTU an hour square foot, provided that the material weight is not greater than 120 pounds per cubic foot. So it is a defined term. All right, let's bump it up now, and we'll go to 402.3, fenestration, prescriptive. Well, before we go there, in table R402.2.6, why there are R30, R38, and R49 under the wood truss ceiling. Well, again, you have to remember that the table, and I'm sure it's 402.6. I think you're talking about the prescriptive table, okay? 402. But in any event, it covers all the climate zones. Like R30 is in climate zone 1. R38 is in climate zone 2. R49 is when you start getting up outside of Florida into areas of the country where it's colder. And that's where you start running into the R49 and such. That's the reason for it. Because again, we're only climate zones 1 and 2. But that table covers all the climate zones all the way up. Climate zone 8, marine 4, and so on. It's all covered. Okay. In addition to the requirements of section R402, fenestration shall comply with sections R402.3.1 through R402.3.5. And here's 3.1, U factor. An area weighted average of fenestration products shall be permitted to satisfy the U factor requirements. And this is a good thing. Absolutely. Okay. This section clearly permits the calculated area weighted average U factor of all the fenestration products in the building to satisfy the fenestration U factor requirements that are in table R402.1.2 or 1.4 for that matter. So as a result, if all fenestration products, your windows, doors, or skylights, if they don't meet the specific values that are in the tables, you can still achieve compliance if the weighted average of all the products is equal to or less than the specified value. You know, works for me. You can also do the same thing with your glaze fenestration solar heat gain coefficients. 402.3.2 goes a little bit more though. An area weighted average of fenestration products more than 50% glazed shall be permitted to satisfy the solar heat gain coefficient requirements. Section goes on to discuss dynamic glazing. Dynamic glazing shall be permitted to satisfy the solar heat gain coefficient requirements of table R402.1.2, provided that the ratio of the higher to lower labeled solar heat gain coefficient is greater than or equal to 2.4, and the dynamic glazing is automatically controlled to modulate the amount of solar gain into the space in multiple steps. Dynamic glazing shall be considered separately from other fenestration, and area weighted averaging with other fenestration that is not dynamic glazing shall not be permitted. Under the exception, dynamic glazing is not required to comply with this section when both the lower and higher labeled solar heat gain coefficients already comply with the requirements of Table R402.1.2. All right, another question here. In the instance of R13.5 in the table, it means not continuous insulation of 13 and continuous insulation of 5. That is correct. The first number is your cavity insulation, and the second number is your continuous exterior insulation. That is correct. All right, let's talk about this dynamic glazing. This came into the code back in the 5th edition. Originally, it was only in the commercial provisions. This technology is similar to solar gray lenses that are in your eyeglasses. This is how it works. Take a look. They're kind of hard to see in the pictures, but if you look real close, you can see these sensors installed on the glass. And the way it works is there's a coating applied to the glass, and a low voltage DC current is run through the glass. As the sun hits the glass, the sensors hooked up to a computer can calculate what kind of solar heat gain the glass is getting hit with. The more sun hits the glass, the darker the tint. Look at these levels. At level 1, the VT is 58 and the solar heat gain coefficient is 0.41. At level 2, the VT is 40 and the solar heat gain coefficient is 0.28. At level 3, the VT is 6. The solar heat gain coefficient is 0.11. And when it's full blown, VT is 1. Solar heat gain coefficient is 0.09. You can still see through it. But that VT and that solar heat gain is incredible. Stuff works. Stuff works. All right. Let's go now and we'll talk a little bit about air leakage. 402.4. This is a mandatory. The building thermal envelope shall be constructed to limit air leakage in accordance with the requirements of section R402.4.1 through 4.5. And then you have an exception in here. Dwelling units of R2 occupancies and multiple attached single-family dwellings shall be permitted to comply with section C, 402.5. And that's probably a good thing because remember, residential provisions go up to 3 stories above grade. So if you're constructing an R2 occupancy, an apartment building or a condo, and it's got 500 units in it, without this exception in here, you'd have to blower door test every unit. But that doesn't make a lot of sense. Doesn't make a lot of sense. They allow you to comply with the commercial provisions of the code. Oh, and I guess I should probably mention that when you go to that section in the commercial provisions, it allows you to do a visual inspection in lieu of blower door testing. All right, next up, thermal envelope, subsection here, 4.1. Building thermal envelope shall comply with 401.4.1.1 and 4.1.2. Sealing methods between dissimilar materials shall allow for differential expansion and contraction. Installation, 4.1.1. The components of the building thermal envelope as listed in table R402.4.1.1 shall be installed in accordance with the manufacturer's instructions in the criteria listed in table R402.4.1.1 as applicable to the method of construction. Where required by the code official, an approved third party shall inspect all components and verify compliance. Now, that second bullet point there about the code official requiring an independent third party, that was put into the code to cover instances when the code official feels that the methods of construction are are such that he doesn't feel that his staff doesn't have the expertise. All right, now the table. Been in the code far back as I can remember. But what I wanted to show you here is this section down here in blue. This was a change in the 8th edition of the code where they tightened up and expanded the requirements for electrical and communication boxes. If it penetrates the air barrier, they have to be caulked, taped, gasketed, or sealed to the air barrier. And any openings with conductors going into or out of the box have to be sealed. Your other option would be to use air-sealed boxes. And we'll look at section 402.4.6 in a little bit here. But right now we need to talk about testing. They put some language in here to clarify the requirements for whole house mechanical ventilation. Testing. The building or dwelling unit shall be tested and verified as having an air leakage rate not exceeding 7 air changes per hour in climate zones 1 and 2, and 3 air changes per hour in climate zones 3 through 8. Dwelling units with an air leakage rate less than 3 air changes per hour shall be provided with whole house mechanical ventilation in accordance with section R 403.6.1 of this code and section M 1507.3 of the Florida Building Code Residential. Testing shall be conducted in accordance with the ANSI ResNet ICC 380 and reported at a pressure of 0.2-inch water gauge, 50 pascals. Section goes on, but just as a reminder, there's nothing new here. This is the way it's been. All they did was add some language to this section to reinforce the fact and clarify that if you test out less than 3 ACH 50, you have to provide mechanical ventilation. Now, as far as the testing goes, there's nothing really new here either, okay? Who can do the testing? Energy auditors, energy raters, Class A air conditioning contractors, Class B air conditioning contractors, mechanical contractors, or an approved third party. Anybody who's gone up to the Florida Solar Energy Center in Cocoa, take their class, take their test, and you're ready to go. Got to give a written report to the code official, no brainer there. But you don't have to do blower door testing for an addition, an alteration, renovation, or repair, as long as the work is less than 85% of the building thermal envelope. And that's a good thing there. You can run into problems trying to blower door test an addition on its own because you're going to have trouble separating and isolating the addition from the rest of the structure. Now, during testing, the code has had a set of parameters, 6 to be exact, of what has to happen when you're doing the blower door test. But really, what I really want to show you here, because this is kind of old news, I want to show you the new news. Look what they added to the 8th edition of the code. Number 7. If an attic is both air sealed and insulated at the roof deck, interior access doors and hatches between the conditioned space volume and the attic shall be opened during the test, and the volume of the attic shall be added to the conditioned space volume for the purposes of reporting an infiltration volume and calculating the air leakage of the home. That is going to make a difference for your blower door testing. Now, keep in mind that this provision to provide the cubic volume of the sealed attic, that's been in the ResNet standards for quite a while. It's just now coming into the code. All right. Next up, fireplaces. These were a bone of contention for quite some time because the code for the longest time didn't differentiate between a site-built masonry fireplace and a pre-engineered unit. They fixed it. New wood-burning fireplaces shall have tight-fitting flue dampers or doors and outdoor combustion air. We're using tight-fitting doors on factory-built fireplaces listed and labeled in accordance with UL 127. The doors shall be tested and listed for the fireplace. We're using tight-fitting doors on masonry fireplaces. The doors shall be listed and labeled in accordance with UL 907. Pretty straightforward. Now, mentioned earlier about NEFRC and testing for air infiltration, and it was optional as far as they were concerned, but that was for their testing parameters. I mentioned that the code does require it. Here it is. 402.4.3 fenestration air leakage. Windows, skylights, and sliding glass doors shall have an air infiltration rate of no more than 0.3 CFM per square foot, and swinging doors no more than 0.5 CFM per square foot when tested according to the NEFRC 400 or the AMA 101 by an accredited independent and listed and labeled by the manufacturer. There is an exception for site-built skylights, windows, and doors. And those are products that are delivered to the job site in a knockdown condition, like storefronts. They're tested for air leakage, but they're tested under a different set of parameters. Now, I'm sure we're all familiar with recessed lighting when it is installed in the thermal envelope. Recessed luminaires installed in the building thermal envelope shall be sealed to limit air leakage between conditioned and unconditioned spaces. All recessed luminaires shall be IC rated and labeled as having an air leakage rate not more than 2.0 CFM when tested in accordance with ASTM E283. That's 75 Pascal pressure difference. All recessed luminaires shall be sealed with a gasket or caulk between the housing and the interior wall or ceiling covering. And John is saying CFM per square foot of the fenestration, not lineal feet. That is correct. It is CFM per square foot. Now, again, we talk about conditioned space. What about sealed attics? They are conditioned space. Because take a look. When you look at the definition of conditioned space, it says C space. And then when you go there, look at D, unvented attic assembly as defined in section R806.5 of the Florida Building Code Residential. These spaces shall not require supply or return outlets. So it is a conditioned space. Now, I mentioned earlier about the electrical and communication boxes and how they've tightened that up a little bit. And as an option, you can use air-sealed boxes under 402.4.6. This is new to the 8th edition. Air-seal the electrical and communication boxes that penetrate the air barrier of the building. Thermal envelope shall be caulk, tape, gasket, or otherwise sealed to the air barrier element being penetrated. Air-sealed boxes shall be buried in or surrounded by insulation. Air-sealed boxes shall be marked in accordance with NEMA OS4. Air-sealed boxes shall be installed in accordance with the manufacturer's instructions. So at least that gives you another option for installing electrical and communication boxes that penetrate the air barrier. Now going to 403 now, systems. Programmable thermostat. Prescriptive. Well, I'm not even going to bother running over this for you for the simple reason that you can't really get anything other than a programmable thermostat these days. You know, the energy code allows you to take a credit for that, but it's kind of like an automatic credit. So anyway, I do want to show you a change here. All they really did was take this section under heat pump supplementary heat and rewrite it for clarity more than anything else. Heat pumps with supplementary electric resistance heaters shall have controls that limit supplemental heat operation to only those times when one of the following applies. One, the vapor compression cycle cannot provide the necessary heating energy to satisfy the thermostat setting. Two, the heat pump is operating in defrost mode. Three, the vapor compression cycle malfunctions. And four, the thermostat malfunctions. So nothing really new there from a technical standpoint. Now, this section is a rather interesting one. We've had this section in the code for quite some time about the minimum R values for insulation. But what's important for us to talk about right here is this new language about ducts buried beneath the building, insulated as required per this section, or having equivalent thermal distribution efficiency. Underground ducts utilizing the thermal distribution efficiency method shall be listed and labeled to indicate the R value equivalency. Well, in the residential provisions, that's all that's there. There's nothing else. There's no definition for thermal distribution efficiency, the TDE. It is in the commercial provisions of the code, it is defined. And it is basically a mathematical calculation where you look at the temperature of the air inside the duct versus the temperature of the air outside of the duct. And that's how you come up with the equivalency. I haven't seen anybody bury ducks under a building, so I don't think we got too much to worry about there. All right. Now, when we talk about sealing, the ducts, air handlers, filter boxes, building cavities, and such, the code sends you to the commercial provisions. Okay. And then it talks about duct tightness, a blower test for the ducts. Duct tightness shall be verified by testing. And there's the ANSI ICC 380. Again, air conditioning contractors, mechanical contractors, energy auditors, and energy raters. But the important question is, when do you have to do a duct blast test? When do you have to do it? Well, you do a prescriptive method, you have to blast the ducts. You do a 405 method, you do not have to blast the ducts unless you take a credit for duct tightness. And if you do a 406 ERI, you have to blast the ducts. And that's pretty much the way that works. Because when you do a 405 calculation, the software automatically assumes a duct leakage rate of 8%. And that's why you don't have to blast the ducts under a 405 calc unless you take credit. Now, that said, you do have to do the testing, and you pressure test to give you two options: the rough-in test, the post-construction test. Rough-in may not have the air handler installed, but the technical provisions either way are the same. Okay. Come on, computer. There we go. And this is what I was mentioning earlier about the 405. Okay. Duct leakage testing is required when credit is taken for leakage. There's your 8% and so on. You don't have to blast the ducts either if they're entirely located within the building thermal envelope. All right. Now, your air handlers. Another difference between the residential and commercial provisions: you cannot install an air handler in an attic under the commercial provisions of the code. You can install it in the residential provisions. However, you can't do it prescriptively, but you can do it under a 405. And of course, we're all aware, I'm sure, what's going on with this puppy here about the warning to the owner about the air handler being in the attic. Okay. So we won't beat that up too much here. Now, of course, the energy efficiencies of your service water heating goes to the commercial provisions of the code, because it's the federal government that sets the efficiencies for energy for water heaters. Okay. So you end up going to the commercial provisions of the code. Now, as far as mechanical ventilation, okay, you've got to provide some kind of ventilation. And the way the residential code is written, you can provide either natural infiltration means or mechanical means. Okay. But when we talk about doing a blower door test and testing out less than 3 ACH 50, you end up having to do mechanical ventilation. Natural ventilation is fine, but it's all about the blower door test. You test out less than 3 ACH 50, and you're going to have mechanical ventilation. Now, this section of the code on the whole house mechanical ventilation system fan efficacy, there is a table in the code 403.6.1, and I want to show you this, okay? Fan location, airflow rates, minimum and maximum, and so on, and the efficacy. Notice that your bathrooms and utility rooms and such, and your inline fans, all of this in blue here, these values went up in the 8th edition of the code. Okay, so they are different. They're more efficient now than they were. Now, I mentioned earlier about running your energy code calculations, worst case, all 4 cardinal directions. Get it to pass all 4 and you're golden. But take a look at what the code says about heating and cooling load calcs. Right here in the first bullet point. Heating and cooling equipment shall be sized in accordance with ACA Manual S, based on the equipment loads calculated in accordance with ACA Manual J, or other approved heating and cooling calculation methodologies, based on the building loads for the directional orientation of the building. And that's the way it really needs to be done. And then it goes on to talk about the manufacturer and model numbers submitted. Doesn't allow for designer safety features or anything of that nature. It's pretty typical. But the big thing is directional orientation of the building. Now, this section does go on. System size and calc shall not include loads created by local intermittent mechanical ventilation, such as standard kitchen and bathroom exhaust systems. New or replacement equipment has got to have an efficiency rating equal to or greater than the minimum required by federal law for the geographical location where the equipment is installed. All right. Let's bring this puppy home. Talk about pools, spas. They are energy hogs, if you will. Efficiency is dealt with in sections 403.10.1.105. And the first thing is heaters. Electric power to heaters shall be controlled by a readily accessible on-off switch, integral to part of the heater, or if it's external, within 3 feet of the heater. Other little tidbits here, big one, and this again is kind of taking care of itself. Gas-fired heaters shall not be equipped with continuously burning ignition pilots. Well, again, the market took care of that. They're all electronic. You can't even get a gas-fired heater with a pilot light anymore. Code also requires a time switch. There are 3 exceptions for it, but for a residential standpoint, you have to have a timer on it. You also have to have a pool cover, unless you meet the exception where more than 70% of the energy for heating computed over an operation season is from site recovered energy, such as from a heat pump or solar energy source. Covers or other vapor retardant means shall not be required. Now, sections in the code dealing with dehumidifiers. And we're not talking about the little plug-in ones that are on wheels. These are permanently installed pieces of equipment. And first thing to remember, the code is not saying you have to have a dehumidifier, because look at the first two words. If installed, a dehumidifier shall conform to the following. So, separate piece of equipment, permanently installed. It gives you the parameters 1 through 4. And we're running out of time here, so I'm not going to go through this. Just be aware that the code differentiates between a standalone permanently installed dehumidifier and one that's ducted into the system. When it's ducted, you meet everything the code requires for the standalone, but you got a bunch of other stuff that you got to comply with as far as where the return and supply ducts are connected. Okay? Goes all the way through. Now, next up, electrical power and lighting systems to bring this puppy home. This is what I consider to be a normal progression in the code. 6th edition, 5th edition, it was 75% or 50%. And then in the 7th edition, it went to 90%. Now, look what it says. All permanently installed luminaires shall have an efficacy of at least 45 lumens per watt, or shall utilize lamps with an efficacy of not less than 65 lumens per watt. Just gets tighter every code cycle. And then last but not least, another problem where the market has taken care of it all by itself. Fuel gas lighting systems shall not have continuously burning pilot lights. Well, again, they're all electronic. And that, ladies and gentlemen, brings us to the end of the presentation. That's all I got for you. And